Hello everybody, my name is Carsten Schütz, I'm Head of Sales at Yoga Technology, and today I'd like to give you some information about the risks that come along with 3D post-processing. Those of you that already manufacture additively know quite well that the 3D printed parts do not come off the machine ready to use. You always have to do some kind of post-processing, and most of the time it has to be done manually. What makes it so very demanding is the variety of materials that is used in 3D printing. You can have very soft materials such as rubber or plastic, and very hard materials, for example steel or titanium. The more materials you use, the more different tools you will need for your post-processing. Apart from this, there is a wide range of conceivable processing steps. That depends, of course, on the manufacturing method and the material you use, but also on the result you want to achieve. You might have to do depowdering, cutting off the panels, support removal, deburring, grinding, finishing, and last but not least, cleaning. That is why it is impossible to do the whole processing in one single machine or with one single tool. In the worst case, you will have to use different devices to achieve your required result. Of course, there are post-processing related risks, and most of the users know the risk for the printed part itself very well, and we normally don't have to explain them. Everybody knows that when, for example, hammering of supports with a chisel, damages to the part can be caused, or it can even be destroyed. What most of the users are not aware of are the risks for themselves that come along with post-processing. Those risks can be very severe, so we will have to focus on them. First of all, there are several risks that come directly with the processing. When doing grinding or deburring, for example, you will produce chips and sparks, so you have to make sure that they don't get in your eyes or hit your skin directly. When working with powder beds, you have to deal with extremely fine and respirable powders. It doesn't matter whether you use non-critical materials such as plastic or critical materials such as aluminium. You surely do not want any of these powders get into your airways, since they are very fine and they go deep into your lungs. What most of the users do not realize is that when they do the post-processing, they produce dusts much finer than the powders themselves. Those dusts go even deeper into your airways and can cause severe damages, even when you're working with generally harmless materials, for example plastic. You can see from this illustration how deep into your airways particles of different sizes can move. Well, some of you might say now that since you're working with powders and particles of 10 to 100 micrometers, there will be no problem. What you have to keep in mind is those are average values. When you do your work with powders of 10 micrometers, there will be particles, of course, much bigger as well as much smaller than this value. Also, as I said before, the dusts you produced in post-processing are much finer than 10 micrometers. Those particles go deep into your airways, and since your body isn't able to cope with them, they will stay there and can cause severe damages. When working with reactive materials, for example aluminium or titanium, there is the risk of ignition or even detonation, and that can easily be caused. All you need are flammable dust particles, which you do have when working with one of those materials. Then you need particle sizes smaller than 500 micrometers. Usually you do have metal powder beds consisting of particles between 10 and 60 micrometers, so here's a check as well. You also need a dust concentration of 20 grams, since you do always have powder remains in your printed parts, hiding in the structure and supports. You can easily outvalue this limit. The last two things you need is an average value of oxygen and some source of ignition. That can be a spark coming from your grinding and deburring, but sometimes the mere friction between single particles can be enough to cause a detonation. So you can't be careful enough. Apart from those direct risks, there are several long-term risks. They are even more frightening because they are usually unrecognized until it's too late. Typical long-term risks are skin and airway diseases. When, after years of working with powders and dusts, skin irritations are the only consequence a user has to bemoan, he can consider himself very fortunate. The airway diseases are much more severe and can start from asthma to black lung, and since the dust particles stay in the airways and nest there, they can cause cancer as well. That is why you have to make sure that you always wear adequate breathing protection and work under safe conditions. So our advice that we can give you is that you pay special heed to the safety data sheets coming from your powder distributor. Also make sure that you store critical powders absolutely safely. Please observe the safety rules in every single step, not just in the manufacturing progress itself, but also in post-processing. Make sure that powders and dusts are immediately sucked away by a proper suction unit. And of course, you have to make sure that the waste materials are safely stored and properly disposed. So that's it for today. And if you want more information about tools or even our Inesca Post Pro workstation for safe post-processing, then contact us or visit us at yokatechnology.com 3D shop. For today, thanks for your attention and stay safe.